Hello friend, today we are looking at examples of homogeneous second order linear differential equations, and our first example is solve the 2y dx squared minus 5dy dx plus 6y is equal to 0. This is a homogeneous second order linear differential equation because f of x is equal to 0. Now, if this equation is given as that, we can also given it in terms of the operators, so that it becomes d2 minus 5d plus 6 cross brackets y is equal to 0. This is the operator. This is the same as what is given here, but when we use the d operator. It means, therefore, if d is equal to m, the characteristic equation of this differential equation becomes m squared minus 5m plus 6 is equal to 0. And this is a quadratic equation which can be solved by any methods. And if we use the factor methods, it means m minus 2 into m minus 3 is equal to 0. Therefore, either m is equal to 2 or m is equal to 3, because we are saying m minus 2 is equal to 0 or m minus 3 is equal to 0. That means m1 is equal to 2 and m2 is equal to 3. Therefore, if we are to use the general solution, which says that y is equal to c1 exponential of m1x plus c2 exponential of m2x, we have already found out the values of m1 and m2, which are the factors of this particular equation. And therefore, if we substitute it in the general equation, it will become y is equal to c1e exponential of 2x plus c2 exponential of 3x. Now, given the boundary conditions, arbitrary constants c1 and c2 can be obtained. If, for example, we have that y of 0 is equal to 0 and the first derivative of y with respect to x of 0 is equal to 1. So now we can find the constants c1 and 2, so the particular solution of the differential equation can be obtained. Therefore, if we have the equation y equal to c1 exponential 2x plus c2 exponential 3x, it means y of 0 is equal to 0 is the first condition. So if it is the first condition, it means 0 is equal to c1 exponential of 2, we put 0 plus c plus, we are saying c2 exponential of 3 into 0. This gives us c1 plus c2 is equal to 0. That can be maybe our equation A. And we go ahead, we put in another boundary condition which says y prime, or the first derivative of y of x is equal to 1. Now, if for us to get the first derivative of y here, it means we are going to differentiate this y with respect to x, so that we know that the y, the x, is equal to, if we differentiate this, it means 2 will come here, so it will be 2c1e, or exponential of 2x plus 3c2 exponential of 3x. Because if I differentiate the x of exponential of 3x, it is 3. This 3 comes here. I will differentiate this with respect to x, then what I get, I put it here, then I will write this exponential of 3x. So that's what I'm saying, and this is still a function of x. So if I have this single prime, or the first derivative of y with respect to x of 0, I'll just substitute my 0 value, which is 2c1 exponential of 2 of 0 plus 3c2 exponential of 3 of 0. Then it means this is equal to 1. Now it means 2c1, because the number to power 0 is 1, it means I will remain with 2c1 plus 3c2, which is equal to 1. This is also equation B. So if I use substitution method, using substitution method, it means C1 is equal to negative C2. So I can call this C and substitute, put equation C in equation B. So that my where I see C1, I put negative C2. So 2 into negative C2 plus 3C2 is equal to 1. Meaning that this is minus 2C2 plus 3C2 is equal to 1. That means this means C2 is equal to 1. Therefore, if I'm to go back to my equation, it will mean that the solution, therefore, will be C1, whereby C1 will therefore equal to, when C2 is equal to 1, then from C, it means C1 is equal to negative 1. Meaning that y is equal to negative exponential of 2x plus C2, which is 1, exponential of 3. So it means y is equal to exponential 3x minus exponential. As simple as. Thank you so much for watching.